Alright, basic blueprint reading. And then, basic blueprint reading, Rick Costin. Open Oregon Educational Resources. Contents, introduction. Cover, the language of lines, visualization, technical sketching, scaling, dimension, auxiliary views, sectional views, machine features, print interpretation. Welcome to the Millennium Belt and Welding Department's first edition blueprint reading. Being able to read, understand, weld, sketch, or even to draw a blueprint important, making accurate parts, complete fabrication. Prints are a tool to communicate what needs to be built, made, what materials are needed, what specifications are required. They ensure the design is made with complete accuracy, what meets the needs of the customer. This book is an updated version originally authored by the Department of Energy, Engineering, and Drafting Technology Department of Lynn Belton Community College in Albany, Oregon. 1. The cover shows the Lynn Belton Community College Welding Department blueprint readings for welders. 2. Language of lines, object hidden section, center, dimension, extension, leader, cutting plane, breaking lines, phantom lines, and borders. You have heard the saying, a picture is worth 1,000 words. This statement is practical concluded regarding the technical drawings. It would be almost impossible to engineer, designer, or architect to describe in a word, shape, size, relationship, or complexity of object. Therefore, drawings have become a universal language. Engineering, designer, technicians, as well as craftsmen, communicate the information necessary to build and assemble service of the product to industry. It's important to remember, as you study the printing reading, that you are learning to communicate with the graphic language used by industry. Lines are part of the language. Since technical drawings are made of lines, logical first step is learn to read drawing, learning meaning of each kind of line. Generally, there are 11 basic types of lines. Each kind of line has a definition, form, and weight. Weight refers to line thickness and width. When combined with the drawing lines provided with the information needed for the understanding for the print, being able to interpret a blueprint accurately build objects is needed for the skill becomes successful in all trades and crafts. It is a skill like many others you will learn. It will take time and practice to fully understand and become efficient. Or your object line is a visible or object line is thickness, continuous line used to obtain outline visible edges and contours of the object. Shows the thick object of the visible lines. Hidden line, as known as the hidden object line, is a medium weight line made of short dashes 1/8 of an inch long by 1/16 inch gaps to show edge surface and corners as cannot be seen. Sometimes they are used to make drawings easier to understand. Often they are omitted in an isometric view. Shows medium dash 1/8 of an inch, 1/16 inch gap, hidden line showing the hidden object side of the line. Section line. These lines are used to cut a surface of the object in section views with the fine dark lines. Various types of section lines may indicate the type of the material cut in cutting plane, and that is a thin grade weight line with section in the cross lines. Center lines are used to indicate centers of holes, arcs, geometrical objects. The very thin size, long, short, long kinds of lines, and they're thin, and it shows the center of the lines that indicate holes or arcs or other objects. Dimension lines are thin and are used to show actual size of the object. The arrowheads are both end of the terminate at the extension line. It's a thin line, shows the dimension of the line of the object. The extension lines are also thin lines showing the limits of the dimension, arrowheads, and touch extension lines. This time it shows the extension line with the dimension, arrow line. Leaders are more than thin lines used to point area drawing requiring no explanation. They're preferably drawn at 45-degree angles. Shows the information at 45-degree angle ray. This time showing the diameter of the inner circle. And there's a thin weighted line. A cutting plane is very heavy, helps you to show the internal shape at a part assembly or slicing through the object. Break lines. These three kind of break lines used in drawings. They are used to remove, break out part drawing for clarity, also to shorten objects which have the same shape throughout their length and may be too long to place on the drawing. So here you have a short break with a thick and a short break with thin and a cylindrical break. And short long breaks used to flat surface cylindricals are used on rods and dowels, etc. Phantom lines are long, short lines most often use the travel or movement of an object or part of the alternate positions. It could be used to show adjacent objects and features, and that is a thin dash line, long line. Borderline. Borders are very thick and continuous lines used to show the boundary of drawing, separate different objects drawn on this one sheet. They are used to separate the title block from the rest of the drawing. And as you can see, they thicken there on the border. Quiz, direction, name, types of lines shown. Check your answers. And, alright, identify the various types of lines. Instructor will provide you a copy. And then, shows the exercise of that. Alright, 3, visualization, perspective, oblique drawing, isometric drawing, 1 view, 2 view drawing, orthographic projection, hidden surfaces, curved surfaces, inclined surfaces. Now that you've learned the kinds of lines found on the prints, next step is developing your visualization ability. The ability to see with the technical drawings and to think in 3 dimensions is the most important part of this course. Some of the most engineering architectural prints utilize some of the form of orthographic projection, multi-view drawing. The type of the drawing will be emphasized. Before you get a study of the orthographic projection, you should be able to recognize several of the other types of drawings. They are 1, perspective drawing, 2, oblique drawing, 3, isometric drawings. As a group, they are called pictorial drawings. They are found on the prints and are easy to visualize, set, look, and their difference. Perspective is the most realistic for the drawing. Artists uses 1 perspective, 2 points, and shown there with a 3-point to create visual depth. Perspectives are used to architecture, industrial, pictorial, plan, layouts, machinery, other subjects for the realism. Object is drawn with the perspective grows smaller and recede into horizon. So this is a perspective drawing, shows the vanishing point horizontal and another vanishing point in the 2-point perspective. Oblique drawings are drawn 1 plane in front of the object parallel to the drawing surface side or other visible parts of the object are generally 30 to 45 degree angle. Note the only side of note that only the side is on an angle. Many times the drawing are not drawn to scale. Receding lines are drawn 45 to 30 degree angle. Will be drawn in different scale, vertical, horizontal line. This makes the drawing seem out of shape. This type of drawing is not used very often in the industry, and this just shows that 30 to 45 degree angle oblique drawing. Isometric drawings have less distortion. Oblique drawings are used in frequent industry for the reason. Isometric drawings have both visible surfaces drawn at 30 degrees. They are the most used type of the drawings. Piping industry taking a great deal of practice, full understand how to draw the best represent being built and would like for the different sides of the one drawing. Show the isometric at a 30 degree angle. Direction. The name of the type of the drawing shown below. Check your own answers. And then, alright, single view is of an object. Sometimes also the needed instant complete. Visual explanation, the different dimension, material, and other information include object requiring only single view is easy to understand. Most 1-view drawings are flat objects made with a material, sheet metal, gasket, stock. Some cylindrical objects such as cannonballs would require 1 view, only 1 view, and not indicating that the material diameter of a spear. The object shown in the 1-view drawing could be made any appropriate material that might be specified with an appearance of the must like a gasket. Used in parting with cooling system on many cars, although we need not to be know of the material type and thickness required. And it shows a picture of a gasket. 2 views. Sometimes 2-view drawings are used on prints. 2 views may also all that need to be shown on the shape of the object. Object is cylindrical, such as the length of the pipe, also shown on the print. 2 views. In such case, 2 views sufficient to explain. Shape. Notice the 2-view drawing shown below the length of the pipe is shown 1 view. Well, the diameter is called out in the other. Without the view of the right, what might the shape be mistaken for? A square or tube channel. Shows a cylindrical as a circular. Cylindrical. It could be mistaken as a square or channel. Orthographic projection. Orthographic projection is a name given the drawings usually with the 3 views selected with the top, front, and right side. Possible course, select other views such as left side, bottom, generally through the top of the front and the right side, traditionally seen by person reading prints. Since the most prints make use of orthographical projection system because top, front, and right sides are most often used. It is important you have the order arrangement on the print fixed in your mind to help you understand the system. Think of the chalkboard eraser, short 2x4 lumber or common brick it looks like this, and shows the top, front, right side. When seen in the print orthographic projection, it would appear like this. Top on the top view, and then front view, and then right to the right side. The system orthographic projection may be difficult to understand and visualize, but it will grasp it. Will some practice their basic example how it works? You simply use a simple object, and then show front view, top view, and right side. Orthographic projection does not show the depth. The object shown above will appear the flat. In the practice of that, however, will learn to scan 3 views, read depth in them. Remember that the location of the top and the front right side views does not change. The projection lines between orthographic views will be show height, width, and depth relationship that exists between each view and the other 2 views. Then it shows projection lines. In case you don't understand 3 views on the last page, let's take another look at the same thing. The time numbers will be with the identification of surfaces. 1, 2, 3, 4, 5. Use orthographic projection object with the surface number to appear like this. 1, 2, 3, 4, 5. Notice the front view of the key object becomes the most clear. The shape of the object tells you the object of the L shape is on the front. The other 2 views don't look so much like them by themselves. By looking at surface of 1, however, you can see that the surface of 2 is taller than 3. Therefore, the reading of surface of 2 should appear closer than 3. But now, look at the 4 and 5. The surface is projected close to you. Answer: surface 5 with rotate and place at the bottom of the layout. Now the drawing is simple block shape, all sides together to form a cube. From a cube by 2 by 2 by 2. Once the instructor has approved the drawing, you'll proceed to cut out and tape the edges together from a cube. Visualization quiz. Direction: all visible surface of the object shown with a number. To complete the quiz, you have to place the numbers on the corresponding surface of the orthographic drawing. And then you would place the numbers on there if we were doing the quizzes. But we're reading this book just for the heck of it. You may wonder at the point something like an orthographic projection prints when is used to print when isometric oblique drawings are much easier to visualize. The answer to both of the type of the pictorials used with a relatively uncomplicated drawing. When an object is complex, however, neither can equal orthographic system from clear presentation, dimension, notes, and configuration details. Hidden surface is another advantage of orthographic projection. It allows you, the person read the print, and the ability to see the inside and surface of the object. But normally they could not be seen with a complicated object. Become very useful. In the drawing below, hidden line right side representing the entire surface of the flat between the 2 and higher sides. So you'd have 2 in the front, and then your hidden surface would be on the side, right side drawing. In the example, the hidden line results in a square hole through the middle of the object. So this is also shown on the top and the side view as a hidden line. There's a square through the whole object. Then we have a little block where the corners cut out, which shows in the top and the front and the side view as hidden lines. Hidden lines example of these there because of the part of one of the corner front surface that is cut away and recedes. Hidden surfaces for the direction. Draw hidden lines for the missing view for each of the problem incomplete view, and then you throw like curved surfaces. Perhaps they're tricky until you remember the curve is also shown in one view. You must put a curve in the other's views yourself through visualization. Try to think that when you're sharp change direction, look at it like a corner, then that will produce a line visible with another view when changing the direction. Smooth like a curve, no line will be seen. Alright, it shows the curves as, here's an example of curved surfaces. It also shows curved surface to exercise. Draw lines missing views, each problem incomplete. Now draw the center lines. And then shows the curved views, they were the problems. Inclined surfaces are those which are angled or slanted. In other words, the surface is neither horizontal nor vertical. In viewing orthographic drawings, you need to be alert to angles. Inclined surfaces are often found with the prints you will be reading later. Note the hidden line of the right view created by the inclined surface on the object. It shows the inclines and the lofted degrees, and then it shows a inclined surface exercise. Draw the lines missing with the use of each of the problem below, and then we're drawing inclined lines for technical stretching. Technical sketching. Technical sketching techniques, letters, oblique sketching, isometric sketching, orthographic spinning, on-the-spot sketching. Many occasions in your work, most likely to be necessary for you to make this sketch. Perhaps you brought to visualize a particular problem with you. without one you find with the necessary to make with a dimension sketch that is shown with the apprentice how to complete the job. And in any case, how knowing how to sketch can make more effective, therefore a more variable trade person. Many times on the field, you're working with sketches, drawing on anything with napkins, cardboard, wood scraps, or a flat surface. Don't get me wrong. We will work projects with professionals producing drawings. Sometimes you have to work with what you have. Being able to technical sketches does not mean you need to be an artist. Sketching isn't difficult. You'll follow the simple rules. You'll be able to a little slow first. But with some practice, you will be able to turn out reasonably good sketches without too much effort. You're not going to be judged with a professional draftsman, person, architect, but you need to be able to describe with lines what you are needing building, repaired, modified. With this practice is very important to skill develop. Sketching techniques, all you need to start with a pencil, some with the paper, soft work, pencil with the best, and the people with number 2, and F for keep the pencil sharp with the note, not the top too sharp, hold it with a grip enough to control, but not too tight to that your arm isn't relaxed. Draw down the heavy as first, and then weighs easier with the erase without smudging, darkening the sketch with it, and begin shaping that up the way you want it. It's generally the best to begin a sketch with plain paper, although some of the people like to use gridded paper on the job. You may find yourself sketching on the back of a work order piece of paper, packing crate. In any case, of learning to sketch quickly and effectively, that's important. Here's some limbering up exercises where you wanted to start with. Keep the pencil sharp and long for many even widths. Try and turn your pencil slowly while completing lines for the exercise below, and then show several boxes. Next, try to sketch the objects in the sketch as much of the example as possible. Remember, sketching means freehand, not straight edges, compass, coins, or etc. Alright, lettering. Now that you've warmed up, you will take straight and curved lines with the stretching exercise. You will then form letters. The entire alphabet can be formed with the straight and curved lines you have practiced. Now, lettering below. If you're printing it similar easily with a readable, skip the exercise, go to oblique sketching. If not, do so practicing some of the work ahead. And tests require good lettering. Remember, the most important requirement of the good lettering is legibility, that there's making a drawing with a person looking at the drawing cannot read the writing, and then it goes over the alphabet. Oblique sketching, the typical pictorial, having one plane parallel to the drawing. Surface visual side sketch at an angle. Usually angle works at 30 to 45 degree. Somewhat between the beginners only have trouble keeping 30 to 45 degrees at the same angle. When that happens, your sketch will look distorted. And it shows counting 30 to 40 and then a 90-degree angle. Here's how to sketch the oblique cube to set up in 30-45. Step 1, Step 2, Step 3. Possibly you might want to show the left side of the cube, perhaps drawn with the hidden lines at the right. In the space below, sketch the oblique cubes that then indicate that these objects oblique is shown. Then it shows these objects in oblique. And if more difficult exercise that you want an oblique, the sketch of the shown in the third problem is drawn with the isometric. Your sketch for the oblique. Convert problem 4 from orthographic to oblique sketch. And then the isometric sketching, unlike oblique, must maintain an angle very close to 30 degrees. Therefore, to get the feel of the isometric, try sketching 30-degree angles in the exercise. So it shows examples of 33-degree angle sketching. Sketching isometric can be done in different ways. Generally, it's recommended that you start at the bottom of the object, box it, and thereby enclosing the rectangular frame. For example, if you were a simple object to look like this, step needed to sketch isometric would be 1, 2, 3. Unnecessary lines, then remove, leaving the object. Once you gain some of the practice at this, it will be possible to make the ISO drawing without guidelines. It is important to use them early on to help train your brain. To the beginner, building a frame before sketching the object often seems necessary, but that may be true with a simple object. However, the things become more complex. The frame gives you the meaning of the means of developing the various parts in an organized way. Without sketching such guidelines, you can easily lose sketch. Sketch for the example, given you the guidelines as shown in the first exercise, drawn by the guidelines light. Note that the 3 and 5 require you the non-isometric lines. Since the lines are not 30 degrees, it is best to connect the end points of these lines after the sketch nears completion. And it shows the more practice objects. Circle and arcs when sketching isometric become elliptical in shape. If the circle is used, it will appear distorted. Example. In sketching isometric circles and arcs, there are 3 positions in which the normally sketched depending upon the surface of the circle feature is located. The surface in the picture planes. Left, horizontal, and right. On the cube shapes below, sketch the ellipses as shown above. You may also want to practice sketching ellipses on other surfaces of the cube. So you've now cubed the drawing for the ellipticals. Orthographic sketching. On all of the methods of making drawing with the orthographic projection is most commonly used with the draft person, although the other methods serve the purpose they can also find show parts of the object as well for the orthographic representation. Orthographic projection system projection from view to view graphically describe the object as a way of reviewing and studying. Views a smaller garage in the strongly notice the location relationship to each of the other views. And now we've given the top right and front view orthographically of the garage. It's important to remember the orthographic sketching is alignment with the top of the view perpendicular project directly above the front view. Front and side view also line up with each other. The height and width of the length of the object must remain the same with the view to view. Therefore, it should be enough distance between the views to prevent crowding and to leave them room for dimensions. Produce a top view in the drawing below, and then there's sketch and object orthographic spaces on the right. And remember, the idea is to project the front and top of the right side view. And this shows some more practice drawings. Alright, on the spot sketching. Now that you've learned 3 different methods of the sketching, it's time to make the sketches that you can make place in front of you and touch rather than sketching on the drawings of paper. Sketch on the spot drawing, standard industry of piece. Machinery needs to be changed, support needs to be added, pictorial information in some way requires a sketch. The instructor will give you an object to sketch. You will now need to produce an isometric object, also orthographic drawing with as many views as required to show the details to the object built. 5. Scaling. Scale measurement, full size, half size, quarter size. The ability to make accurate measurement of basic scale that everyone reads and uses. Blueprint sections intended with a review fundamental principle of the measurement. So some students have little need for the measure accurately. These exercises provide practice they need. Others who have made more experience may need to exercise a worthwhile review. Whether or not you need to review these fundamentals, there's one important thing to remember without getting measurement from the print. If you need dimensions is unclear, is not given due to the not measure of the print. Since the print shrinks and stress, they may not be drawn to scale. You can easily come from with some inaccurate measurement. Scale measurement. Drawing an object may be same size of the object, full size of it may be larger, smaller than the object. In most cases, if it's not drawn in full size of the drawing is made smaller than the object. This is done primarily for the convenience of the other user of the drawing. After all, who wants to carry around a full-size drawing of the locomotive? Obviously, with the object small as a wristwatch, it would be necessary to draw a large scale. Machine part with example, they must have at least 1.5 to 1 inch, 1/2 inch to 1 inch, or a building may be drawing 1 to 48 size, or 1/4 inch equals 1 foot. Map may be drawing 1 to 200 size, is 1 inch to 100 foot, and a gear wristwatch may be 10 times is 10 inches to 1 inch. There are numerous scales. Different needs seen in each occupational group. There's frequently used scales. Some of the practice basic for you, help you to work the scales using technology. Full scale is simple, letting 1 inch on the ruler, steel ruler, draftsman scale equal to 1 inch on the actual 1 inch on the actual draw object. Rulers of this kind usually divided in 1/16, 1/32 of an inch. The first measurement exercise will be the full size. If you can measure accurately in full scale, you want to skip ahead. Here's a big inch. Each space is 1/32 of an inch. Have not been worked with accurate measurement. Spend some time studying measurement practice on the scale above. Locate the following fractions, and then directions. Each fraction below is numbered right. The number above the scale point with the arrow with the fractions located with the number, and this is just basic ruler. Half side of the principle of the half side measurement drawing. Simple, letting a unit such as 1/2 inch scale represent a larger unit such as 1 inch on the drawing. If the drawing is properly labeled, the word half size 1/2 inch equals 1 foot will appear on the title block. Using half size scale is not difficult, but does not have some practice for the max. Might measure the distance 2, 3/16 of an inch. You look at the first of it, then go for the 2, then you go backwards from the 0 and count off the 3/16. Measure the way each dimension through the fraction. Whole numbers, number side without fractions are measured in the usual way. Next, locate half size available in the lab. Measure the lines below the nearest 1/32 of an inch, right the length of the line space provided. Because paper is dimension unstable due to the humidity, the exact answer for the half side of the measurement practically cannot be given, but this is another reminder of the poor practice of measure of the piece of the paper. Quarter size is used to read any similar way with the half size, except that each of the units, such as the quarter of an inch, represents the larger unit, such as 1 inch. If the drawing is properly labeled, the words of the quarter size or quarter scale, 1/4 inch equals 1 inch, will appear on the title block. The quarter size scale is used in a similar manner with the half size scale. With the quarter size practice, draw lines or areas provided with the required length. Here, have another student or lab instructor check your line accuracy. And then their quiz. Alright, 6 dimensions. Numerals, dimensions, extensions, arrowheads, dimension figures, isometric dimensions, or orthographic dimensions. If you're drawing with a complete with this, so that the object presented with the drawing can be used, made intended for the designer, it must be a 2 complete story that tells of the views, describe the shape of the object with the dimension, know that will give the size of the other information needed to make the object. Therefore, your next step is to learn the basic dimension in the way that you understand not only how to interpret the drawing to get information you need, but also the dimension of your sketches so that you can be used to communicate size information to the others. Numerals. It may seem a bit basic for the exercise. Shape of the numbers comes with the forward dimension of the reason such view of the review. Simple and incorrect, careless made numbers of the drawing, but the sketch can be easily misinterpreted by someone on the job. That can be costly. Therefore, the shape of the members and forms is justified by the number of forms presented have been determined to be most legible used in the industry nationwide. The United States standard 1/8 of an inch. Vertical numbers are correctly formed as follows. Our dimension lines are fine, dark, solid lines with the arrowheads. Each of the ends indicate the direction extent of the dimension. Machine sketching and drawings with fraction of the decimals are used for dimension. The dimension line is usually broken near the middle, provide an open space for the dimension numerals. The architectural and structural sketch of the drawing, the numerals are usually above an open broken dimension line show the machine dimension. Architectural scale of the dimension indicate the dimension in which closest to the object should be placed approximately 1/2 inch away. The other dimension beyond the first dimension, if any, should be approximately 3/8 of an inch away. If you need not necessarily have any, should you remember not to crowd your dimension line. Keep the uniform distance apart. But the most important thing of the drawing need for the claim of the dimension need to be located in the space wherever they cannot be confused with the surface not intended to be used from how the dimension should be sketched. Show the inner dimension 1/2 inch from the object outer dimension. The dimension less than 6 feet or 72 inches given in the inch of the dimension of the over 6 feet usually shown with the 5 feet and inches. Be sure that you're clearly how dimensions are called out with calling out with the dimension over the 12 inches to make sure all the dimensions are called in total inch and feet throughout the entire drawing. And 4 foot 5 inches or 50 inches, they both mean the same thing, but there's a mix of the dimensions that can become easily 4 foot 8 inches, as you see 48 inches. Extension lines are drawn with the fine dark solid lines extending with the outward of the point of the drawing in which the dimension referred to the usual dimension line meet the extension line. At right angles there should be a gap about 1/16 of an inch for the extension line would meet the line of the object, and the extension line should go beyond the outermost arrowhead approximately 1/8 of an inch. Also, there should be no gaps. The extension lines cross. Note this example: the large dimension correctly placed outside beyond the short dimension. The dimensions are preferably not drawn with the object itself. Sometimes, however, the necessary dimension on the object. And then show the extension crossed without gaps. It's important to remember to place the dimension on the views. In 2 to 3 view drawing with where they will be most easily understood. Avoid dimension with a hidden line. Avoid with a duplication of dimension. Use the common sense with keeping the dimension clear and simple as possible. Remember, the person reading your drawing needs to clearly understand beyond the question how to proceed with the otherwise costly and time the material will be wasted. There are 2 basic methods of placing dimensions on the sketch. There may be placed with the read for the bottom of the sketch with an unidirectional dimension from the bottom and the right side angle dimension, or unidirectional, usually best because of the most easily reading by working. You have unidirectional dimension and then a line dimension. When dimensions are not fit in the space, usually the other methods use the dimension clearly with the crowded condition exists. Standard procedure and alternatives. Just standard procedure and alternatives for angles. Arrowheads are placed at each end of the dimension with the leader of the line, etc. with the correctly made arrowhead about 1/8 of an inch, 3/16 in length, and are 3 times as long as they are wide. Usually they have a slight barb, much like a fish hook. They may make your drawing look clean, and usually the same style throughout the drawing and sketching. Shows a correct arrowhead and incorrect arrowhead. Dimension numerals. Numerals give the dimension object with normally 1/8 of an inch of the height. When dimension includes the fraction approximately 1/4 inch height, making the fractional numbers with the slightly smaller to allow for the space above the fraction line. Fraction line 1/4 inch in height. Again, it's practical and important with the numbers and fractions. You may put the sketch and drawing in legible. Sloppy numbers can cause expensive mistakes. Notes used the drawing or provide supplemental information. It should be brief, careful, worded to avoid being misinterpreted. Located on the sketch for the uncrowded area with the later lines going to be the note should be kept short and noted that usually added after the sketch have a dimension. Avoid interference with the dimensions. Alright, then it shows some pictures with the dimensions and then a quiz. Oblique dimension is most remembering to avoid dimension on the object itself when possible. The use of the common sense dimension principle. It's usually best to have the dimensions read with the bottom unidirectional as shown here. And it should run from the bottom. Although it's best not to dimension the view itself, they usually accept the practice for the place of the diameter, radius, dimensions on the view, and space for the permits. Sometimes space and time limited must have within the typical rules drawing a dimension. The most important thing is to keep the drawing clean, concise, and try not to repeat the dimension, but give all the required ones in direction completed as indicated. Dimension of 3-inch cube. Source section of the rod 5/8 of an inch, diameter of 2 and 1/8 of an inch long, with the longer section of the 7/8 of an inch into with a diameter of 3.5 inch longer dimensions of the drawing. Isometric dimensions. When dimension isometric sketch, it is important to keep the dimensions away from the object itself. The plate with the dimension on the same line with the surface of the object with the dimension that you probably find with the two that the dimension will isometric to the sum of the practice, and then show the place note with the isometric with it regarding to the plate with the same plane with the dimension, easier to do with easier to read. Alright, now you see the 3/8 of an inch ream into the plate. Isometric notes have to be done on the same plane. Notice the example above the part with each of the leader line when the notes are sketched in approximately 15, 30, 45, and 60, 75 degrees. This is done to avoid confusion. Other lines never draw leader lines entirely horizontal or vertical. And then there's a quiz. Orthographic dimensioning. When you look at the dovetailed object several pages back, it's easy to see where the isometric sketch can be quickly become cluttered with the dimension to cover the more complicated sketch for the drawing dimensional orthographic. The method provides the best way of the dimension clearly and detail the some of the general rules to follow when dimensioning. Show enough dimension so that the entire intended size can be determined without having the workman calculate and assume any distance. State each dimension clearly with the understanding one way. Show the dimension between the point lines, surfaces which have the necessary relations to each of the other, which control the location of the other components of the mating parts. Select a range of dimension to avoid accumulation of the dimension that may cause unsatisfactory mating of the parts, or in other words, provide the build-up of the tolerance as in the example below. Show the dimension only once. Do not duplicate dimension when possible. Dimension each feature in the view whether it appears most clearly when it's in true shape, it appears when possible. Specify the dimension and make use of the readily available materials and parts and tools. Note if the dimensions are correctly placed between the view rather than around the outside of the edge of the drawing. And then there's a quiz. Chapter 7, Auxiliary Views. Front view, auxiliary, top view, auxiliary, side view, auxiliary, sketching, auxiliary views. When object is slammed with the inclined surface, it is usually not possible to show the inclined surface with the orthographic drawing without distortion. Present with a more accurate description of many inclined surfaces. Additional view not known as the auxiliary view is usually required. Auxiliary views is simply a helper view which shows slanted part of the object actually turned with the project with the object with the true size shape of the surface ace or surface is shown seen in there actually are. Auxiliary views are commonly found with many types of industrial drawings. Front view auxiliaries. There are three basic types of auxiliary view. The first type of the auxiliary view projected for the front view, the three view for the orthographic drawing, and the second and third type of the drawing of the auxiliary views are projected for the top and side views. Here is the front view auxiliary with a simple object with its inclined surface. Just inclined surface and the auxiliary views. Notice that the projection line perpendicular with the slant surface of the first view, but the only slant surface of the object is shown with the auxiliary view, but the rest of the object is omitted. However, the clarification portion of the adjacent surface is sometimes shown, but also notice the slant surface over the top and side views are shortened because of the distortion, whereas the surface auxiliary view is true in the actual size. This discussion of auxiliary views being an orthographic view of the object with projection lines perpendicular to 90 degrees, slant surface adding the reference of the line and convenient distance from the view of the slanted surface. Once again, you got your reference line, and then we're making a selection, top, right, left, slanted view, where you see A to B as your reference line. Notice that C and B auxiliary view may be made in the same length with the related distance of the orthographic view is an example of side view complete with the C and B. Now we have A, B, C, and D for auxiliary view. Top view auxiliary is developed in the same way with the front view auxiliary, except the auxiliary is projected with the top view, with the auxiliary view with the projection for the front and top side view depending on the position of the object, of which surface of the object is slanted. Example of the top view is slanted, therefore the auxiliary view must be projected with the top view. Again, notice that how the angled surface shown in the front and side views are not shown. Alright, so now we've done the top side and we've made our auxiliary view. Side view auxiliaries are drawn the same way with the front and top view. Again, the auxiliary view is projected depending on the position of the object and surface of the object is slanted. So this is done with a slide view slant. Obviously, there are very basic auxiliary examples are presented with the introduction of the concept of auxiliary views, as objects inclined to become more complex with auxiliary views provided with the meaning of the representing of the project with the true size and shape. Sketching auxiliary view for the problem required with the auxiliary view to complete with the sketch auxiliary views required space provided, and then drawing 2 practice, drawing 3 practice, quiz 8 sectional views, cutting plane line, section line, half section, full section, broken out section, revolved section, offset section, removed sections. You've learned when making multiple view sketch with a hidden edge surface are usually shown with a hidden dash lines. The object becomes more complex. In this case, the automobile engine block clearly presentation interior that can be made with the sketching object that would like to be cut apart in that way, that many hidden lines of the sketch are eliminated. Process of the sketching internal configuration of the object shown with a cut apart. No sectioning, section U, the frequently own wide variety of the industrial drawing. This example blocks A and B result of the block in figure 1 has been sectioned. When you cut an apple in half, you've sectioned it, and just an apple can be sectioned any way you choose, so you can object with the sectional view with the drawing of the sketch. So there we have the drawing of the 2 sectional views. Cutting plane, surface the cutout with the result of the drawing above the cutting plane, actually with the measuring cutting plane taken through the object, since the object is imagined as being cut through at a desired location. Cutting plane represented with the drawing with a cutting plane line with a heavy long, short, long kind of line terminated with the arrow of the arrow showing the direction of the view. Once again, have a graphic example of the cutting plane line with the section that develops it from. Here's the object of the cutting plane and the resulting section line lines of the figure above whose like the solid mark for the call of the section line with the file on the most sectional view of the indicated surface that has been exposed with the cutting plane. Note with the square hole of the object with non-section lining, since it was not changed by sectioning. Different kinds of section lines usually identified with the different material of the object and made with the combination of materials variety. Section line symbol to make some material with identification easier. Here's a few examples: net, brick, honeycomb, stone, and section line very limited. Section line is very slight. The sectioning of the object of the part of the required section view of the drawing with the angle approximately 45 degrees space with 1/8 of an inch parts under the offset of the section must be drawn with care. If it's the best, use the symbol of the material being shown as the section on the sketch. If the symbol is not shown, you may use the general purpose and symbol the way you achieve the symbol for the cast iron full section. The cutting plane line presently passes entirely through the object of the resulting section line called with the figure 7 illustrates full section. Here's the cutting plane going through the entire section. Isometric on the side in the full section cutting view. It's possible to section an object when the closer initially is desired. Here is the object section in 2 directions. Alright, half section. Cutting plane is placed in halfway through an object, one quarter of the object to remove the resulting section of the half section. Half section has the advantage of showing both inside and outside configuration. Fitting with the symmetric object, but the hidden lines are usually not shown in the unsectioned half unless they are needed to clear an inch of the dimension purpose on all sections, drawing with the cutting plane with the taking precedence over the center line. Alright, so here we have a quarter section or a half section, quarter section cutting plane presiding over the center. Identification letter not only on the section shown. Here's an area where the left half of the section. Remember, the only fourth of the object is removed with the half section, as the object is removed from the full section. Cutting plane center visible line. Manufacturer's drawing either both half and full and half sections illustrate the advantage. Section view the different line with the direction identified with the different parts materials used in the assembly of the valve. Here's a valve, electromagnetic locking pin, single oil feed, center bolt, integral control valve. So that's a section view, and then there's some quizzes. Alright, broken out section. In many cases, only a small part of the views need to be sectioned in order to show the internal detail of the figure below. Of the broken out section, remove the freehand break line. The cutting plane line does not need to be sewn since the location of the cut is obvious. Show the broken out cutting line. Revolve section. The revolve section shows the shape of the object, rotating section 90 degrees within view. The three revolved sections illustrate the spear-like object in figure 12 show the change that takes place in the shape. Off section means that including a single section, several features of the object with a straight line. To do this, cutting plane line is bent, and the offset is to pass through the features of this part, and then show the cutting plane line offset. Remove section. Section removed with the normal projection position standard arrangement of the views. Remove sections. Such sections labeled as section A, section B, etc. corresponding to the letter of the designated at the end of the cutting plane. Review the section made the material part of selection and often drawn with a different scale. Then there's a quiz. 9. Machine features. Bevel, boss, chamfer, counterbore, countersink, dovetail, fillet, curve, keyway, key seat, knurling, lug, neck, pad, round, spline, spot face, T-slot. Machine features section common terms related to the basic industry process. The terms are often found with the prints. More or less understanding of these processes. Look at the models of the machine feature of the printer reading lab. Bevel, shift the cutting angle of regular welding. Bevel will normally end up with a surface prep for the weld. A boss is a circular pattern forging casting which projects from the body of the part surface of the boss machine smooth with the bolt head to see, and it has a hole drilled through that can accommodate with the bolt and shank. They show the boss. A chamfer is a process cutting away with the sharp external corner edge, not for welding. Counterbore and enlarged drill hole to give the diameter and depth, usually done with recessing a bolt head. Countersink the machine, a cylindrical dimension of the drill hole, recession, flathead, screws and bolts. Dovetail, slot depth of width that has been angled sides. And then the quiz directions of those. Fillet, a small radius, filling a form between the inside angle of the two surfaces. A curve, narrow slot formed for the removing material while the sawing or other machine. Keyway, a narrow groove or slot cut into the shaft holds the sleeve of the hub of the accommodating key. Narrow key seat, narrow groove slot cut in the shaft of the accommodating key. Kernel, uniformly roughened with a diamond straightened pattern and cylindrical flat surface. This is diamond pattern, straight pattern. Like a piece of project out of the body of the part, usually rectangular cross section with a hole or slot. Neck, the machine narrow groove the cylinder part of the object. Show the V groove, square groove, and around. And additional features and shapes. You have the pad slightly raised surface projecting out from the body of the part. Pad surface can only be any side of the shape. Remember, the bosses can only be round. Small radius round outside corner formed between the two surfaces. A spline gear-like serrated surface on the shaft that take the place of the key when more torque strength is required. A spot face round surface of the casting forging for a bolt head, usually about 1/16 of an inch deep. T-slot, a slot any dimensioning resembling a T. And then quiz and directions. 10. Print interpretation. Print interpretation final section introduced the basic print reading because machine drawings use the some extent nearly every trade working drawings use this section. All machine drawings. Purpose of the package to provide opportunity to put the fundamental knowledge of the print reading used before going on to more specialized advanced print reading activities. Exercise 1, Exercise 2, Exercise 3, Exercise 4, Exercise 5. And that was completion of basic blueprint reading. Rick Costin, Open Oregon Educational Resources.